For chapter 7, we're talking about continuous versus discrete. And we're going to talk about a term, normal distribution. And from now on, we're going to have problems that say, assuming that this follows a normal curve. That's that bell-shaped curve. And that's what we're going to be dealing with from this point forward when we talk about hypothesis testing, everything. So, but uniform distribution is a very simple form of distribution. On the in-class test, I might ask you, what's the shape? If I ask you, what does something look like, I'm talking about what's the shape. So it's either skewed or not skewed. It's a normal curve. It's a rectangle, whatever it may be. So if I ask you what something looks like, I guarantee I get the answer, numbers, data. Now I want you to graph it and see what does it look like. So in this case, I have uniform distribution, which just tells me where my data lies. And it's very, uniform distribution has very absolute ends. There's no way you can get on this side or this side. It's rectangular shape, has very defined maximum minimums. When we talk about normal distribution, we're going to talk about areas in these tails that you can't ever say 100% something's going to happen. So if I say that most likely the person, if you come to class every day, you will at least make it a D. There's always that one chance that you'll have somebody in those outliers. So uniform distribution doesn't take that into account. It says, this is it, this is it. But normal distribution is going to say we'll have these outliers that we don't know anything about, so we have to accommodate them for them. The uniform distribution, I want to figure out what the mean of that is, so it should say A plus B divided by 2. So my minimum is 0, my maximum is 30, divide by 2, my mean is 15. Because everything is normal. It's a square or a rectangle. If I split it in half, I'm going to have equal sides. When we deal with normal distribution, it's a little different. To figure out the standard deviation, remember the variance is just taking this and squaring it, so taking off the square root side. B minus A squared divided by 12. Like I said, you'll have very basic problems about this, but this isn't what we're concentrating on. Uniform distribution, the probability that something happens is just 1 divided by the minimum and maximum. It's always the same probability that you would get 10, if it's, you're talking about, I think it's the minutes that they have for an example. This is about buses arrive between 0 minutes and 30 minutes. They do not, nobody arrives after 30 minutes. Of course, nothing can be before 0 minutes. So we're dealing with that type of data. It's always going to be the same probability. So what's the probability the student will wait between 10 and 20 minutes? What's the probability that they'll wait more than 25 minutes? So here is what it looks like graphed out. 0 to 30 minutes. I've come up with the probability of any of these things happening. Probability assuming, again, that everything is equal, which is why we don't normally use this because you can't make that assumption. But everything is equal, that you will have a same probability of getting there 10 minutes late or waiting 10 minutes as you would 20 minutes as you would 30 minutes. As you would being instantly the bus is there. Show the theory of this distribution is 1. So pretty much what you're doing, when you talk about probability, you're talking about area under a curve. This curve just happens to be a rectangle, so it's very easy to calculate area. It's just a side times the side. That tells me what the area is. Same thing here. I have 30, what I'm figuring out is the length here. 0 minus 30 is going to be 30 divided by 1. Times 30 minus 0 is going to be 1. That's all that's doing is telling me that the area of this entire rectangle is 100%. And that everything else is divided again. Probability for each one of these things happening would be this 0.03333. Again, we're not really dealing with this, so it'll be, I think it's a little bit easier when we deal with the other curve. So again, I'm just going to have very basic questions about this. We'll work through some problems. And here's what I talk about with area. Area is going to be the, or with probability, it's going to be the area under that curve. And again, this curve is a rectangle. So area is going to deal with probability. If I figure out what the probability or the area is of a square, that's the probability of something happening. It's easy to think of it like a dartboard. And what's the probability of actually hitting the dart in a particular area? Well, the easiest way to do that would be to figure out the area of the entire circle and then the area of each one of those little sections, and you'd be able to figure out what's the probability that I actually hit in that area. And that's the exact same thing we're doing here. What's the probability that if I grab somebody at random waiting on the bus, that they wait between 25 and 30 minutes? It'd be a 16.67% chance. and that's going to be the same area as it would be picking somebody from 0 to 5 minutes or 5 to 10 minutes. It's the interval length that's going to determine that probability. I may want to figure out what the probability is going to be on either side of this mean. The mean is going to be the division point. Again, with the rectangle, it's kind of hard to look at. So we'll go through examples with normal probability. Normal probability is always going to be symmetrical around the mean. The mean is in the middle. If I ask you what the mean is, it's in the middle. And the mean, median, and mode are most likely always going to be the same, around about the same. That makes it a bell shape. That makes it symmetrical. Asymptotic means that the x-axis is never going to touch with the curve. The tails are indefinite. They go on forever. So we don't know, again, those outliers. You may have that one person who doesn't go under that curve. And that's why you can never say 100% true that you've proven something, because you always have a chance of that abnormality. The location of normal distribution is determined by the mean and the standard deviations. Now I drew out what standard deviation meant, so that's what we're going to be using for these chapters. The arithmetic mean, median, mode are all going to be equal, or pretty close to it. Sometimes you mess up on a calculation and it's a number off or a point off, but in general it's the same. And the total area under this curve is 100% or 1. So we're going to assume that one half would be 50%, the other half would be 50%. So let's look at a drawing. This is what a normal curve will look like. Sometimes this peak is higher or flatter. It depends on what the data is. But basically, I just draw the same curve and I work on all my problems the same way. My mean, median, mode are all going to be in the middle. And so that means 50% of the data lies on this half and 50% of the data lies on this half. We talked about before those standard deviation points, and that's going to kind of tell me how many each one of those standard deviation points, the 1, 2, and 3, and the negative 1, 2, and 3, each one of those have a value that you've calculated from your problem. And we'll go through examples. Standard deviation, it's also called the z-distribution. So we're going to calculate something called a z-distribution, and it'll tell us where to go on the number line. And this is my formula. It's going to be x minus the mean divided by the standard deviation. So this is what I'm talking about with figuring out area under a curve. There's a table in the back that tells us all of this, so we don't have to calculate what this area is using our calculus and trigonometry and everything to try and figure out what that is. They've given us a table in the back. All you have to do is figure out where you are on this number line down here. So again, we're going to go through examples of this. I want you to work through some of your problems, but we'll go through how to work this out in more detail on Friday. So let's go through an example. We have weekly incomes for shift foreman at this glass industry. It's a mean of $1,000 and a standard deviation of 100. So let me draw it out for you. I think this is warmed up enough. Here we go. Okay, so the first thing I always tell you to do, draw out your normal curve, which I already have here, so I'll just draw on this one. So I have my normal curve here, and it'll always be the same for everything. I can get this to move up. I hate that this is backwards. So it's always going to be the same curve for everything. What I do is I draw this out to the side and I get either transparency or I just make a couple copies. So every time I do a homework problem, it looks the same way. And these are always going to be the same standard deviation points. So I always have 1, 2, and 3, and -1, -2, and -3. And if I look at my problem and look at this graph, then it's a little bit easier to see what's going on. So the first thing it says is that the mean is 1,000. The mean, median, mode are always here. This line is going to tell me the standard deviation. This up here is going to tell me what the value is to the problem. So this is always the same. This is always -3 to 3, always. Up here is what's going to tell me what's the value. So if I have $1,000 here and my standard deviation is 100, so that means each one of these points that I move over, it adds 100 or subtracts 100 from that mean. So if I look at where these correspond, what would the value here be? 1,100, 1,200, 1,300. I'm adding, this is the positive side of a line, I'm adding 100 standard deviation points for each one of these that I go over. I do the opposite here. What would it be here? 900, 800, 700. So I can look on here and say the majority of the people working at this glass firm make between 700 and 1300. I can look on there and logically say that. We had that graph in the other chapter that said that 68% of the data lies between here and here, 95% of the data lies between here and here, and 99.9999% of the data lies between here and here, because again, we can't say 100% because this line never touches the x-axis, so there's never an ending point that we're very certain of. Now we know that zero, they can't make negative dollars, and they're probably not making $1 million, but theoretically it says 99.999. So I can look on here and make estimates about probability. So the problem says, what is the z-value at $1,100 a week, and what is it at $900 a week? Now, since I've drawn it out, I can tell. But the z-value formula is going to be x minus the mean divided by that standard deviation. So the x I'm looking for is 1,100. They want to know what's the z-value, what's the value on this line at $1,100. Well, since I've drawn it out again, I know what it is right here. But the formula says I do $1,100 minus the mean divided by the standard deviation, which would come up with 1. That tells me its z-value is 1. Right here, these correspond. So that's telling me where it is on this line. When I look in the table in the back of the book, it tells me what is the area right here. So what would be the probability of somebody making $1,100? You could look in the back of the book and it would tell you, but we're not getting to that point yet, just so you can visually see how we're working out these problems. So as far as our homework and lecture is concerned, we'll stop at this point as far as calculating the z. I want you to be able to calculate the z. Z's can be negative or positive. Most likely what you're doing, at least right now, they're not going to be over 3, 3.5, maybe 4, and negative 3. But sometimes you'll have these problems where you'll get a 12 or a negative 13, and that's okay. That just means it's one of those extremes. Here's this table that was in the back in the other chapters before. 68% of my data lies between -1 and 1 standard deviation point. 95% of my data lies between -2 and 2 standard deviation points, and most, practically all, again, I can't say 100%, lies between -3 and 3. I don't think we're going to do this one. Okay, so when we get to that point, we're going to start looking at the area in the back of the book. So now we're going to stop right here for Chapter 7, and we're going to get out our Chapter 6 homework and split into groups and work through that.